So this is fantastic. I mean, right out of the box, it does a great job. Oh my, that is good. That is actually a much better version. So you can actually see some of what it's doing right now. So it's actually working really, really hard on this. That is actually the answer. That is absolutely incredible. Great job, O1. And oh man, it fails right at the beginning. Look at that. It just says you're going to be able to do it in 15 over 5 equals 3 trips. That is incorrect. So the rest of the logic is broken. And holy crap, turning back, look at this. The answer is D plus or minus 1. Holy mackerel. That is amazing. So that is by far the best answer that I've had from any of these models. Hey y'all, it's Dr. Know-It-All. I'm super excited to talk about OpenAI's new ChatGPT-o1. I guess that's what it's called. But first of all, a huge congratulations to the Polaris Dawn team and of course SpaceX for doing this amazing spacewalk yesterday. If you haven't seen the video, find it on X or YouTube and rewatch it. It is really pretty astounding to watch these, private citizens be able to do something that looks very much like the old days of the Gemini space program with tethered spacewalks and everything. So yes, it's just a first step, and Jared and Sarah only spent about, I think, 10 minutes each or so outside of the spaceship itself, standing with the porch. I think they call this the porch. But anyway, they were able to test out the suits. The suits worked, which is remarkable because again, remember, this was developed by SpaceX in the course of just a couple of years, and they were able to wear these internal to the cabin. So they're not only EVA suits, they're also suits that they can wear in the cabin. So anyway, if you haven't seen my chat with Kid Poteet yet, I will leave a link up here and in the description because I think it's highly worthwhile. But let's turn to ChatGPT-o1. So this is going to be kind of a hybrid video. I want to do a quick review of what we know about ChatGPT-o1. Unfortunately, OpenAI is not very open about this. They don't tell us a great deal about it. But then I want to run ChatGPT-o1 through some tests. I have not used it at all at this point. I know that there is a limitation to the number of tokens you're allowed to produce per week. I think it's not even per day, but per week. So I don't want to use it all. So we'll get to discover how good it is together. I have added a couple of different questions because the whole point of O1 is that it's supposed to be much better at reasoning, math skills, things like that. I've sort of, rearranged my test to focus on that. Anyway, I want to start with this figure and this paragraph. This figure, Jim Fan yesterday posted on X and said this is one of the most important figures that we've seen in the AI world in the past several years. And it might not look like much at once, but let's take a look at it first and kind of understand it, or grok it, as I was saying. So anyway, what we have is train time compute and accuracy. And this, of course, is for O1, ChatGPT-o1. And notice that the train time compute is on a logarithmic scale. So this is exponentially longer and longer times to do this. But basically, as you exponentially increase the amount of time that you spend doing training, you get better and better results. Now, what this means, because this is a line, is actually it's going to tail off like this. So it's going to be marginal returns as you increase the amount of compute. But if you can increase the amount of compute exponentially more and more and more, you will still get better and better results. So this is something that probably everybody has already seen. This is train time compute. This is the kind of thing where you're doing your reinforcement learning and all of that kind of stuff. This is the interesting part of the chart over here, which is test time compute. And basically what they're saying is same thing. You've got a log scale. If you throw exponentially more and more and more compute time at the model at inference time, in other words, this is a pre-trained model, but if you say, think about this for longer. So instead of spending 10 seconds thinking about it, spend 100 seconds or 1,000 or 10,000 seconds, right? You can keep increasing the amount of time that it can think about complex problems. And what you notice here is that it scales up. You get significantly better results if you allow O1 to think about this longer and longer. Of course, this is related to Strawberry and QStar. If you haven't seen my videos about that, I will leave some links up here and also in the description. I don't have time to go into QStar and Strawberry in great detail today, but basically Strawberry / QStar, the whole point of it was to take a question and an answer and have QStar develop the rationale, the internal thinking part, the internal monologue. In other words, if somebody asks you a complicated question like a hard math problem, you in your brain, and possibly even on a piece of paper with a scratch pad, will write down the solutions. You'll figure it out. You'll kind of iterate on it. You'll think about it for a while and come up with the answer. And the whole point of QStar was to develop that internal monologue. You give as input something where you know the question and you know the answer, and then we actually do know what the thought process is. But the goal of the model is to figure out what that thought process is and then compare that to the ground truth process that that we already knew. And that's the basic training. And then I think they're able to bootstrap that and not have to have that internal monologue after you have, enough examples, several tens of thousands of examples or something. It can go on and bootstrap itself. Unfortunately, OpenAI doesn't really tell us a lot of information about that, so we don't know for sure, but that's my guess. Anyway, as the highlighted paragraph here says, our large-scale reinforcement learning algorithm teaches the model how to think productively using its chain of thought in a highly data-efficient training process. So it's a training process that teaches it how to think about that internal monologue. We have found that the performance of O1 consistently improves with more reinforcement learning, train time compute, and with more time spent thinking, test time compute, or inference compute. The constraints on scaling this approach differ substantially from those of LLM pre-training, and we are continuing to investigate them. So they call this a preview. They're not saying that this is a done deal or anything like that. They're just showing us what they've got. Unfortunately, what we're going to find out is they won't show us the chain of thought. They're only going to give us kind of a summary. It's a little bit similar to Tesla's full self-driving display, where it shows us what it thinks the system is visualizing but doesn't really know. The motivation behind O1 is very different, however. For full self-driving, the display model just doesn't even really understand what the thinking model is doing, the full self-driving compute module is doing, so it has to kind of interpret it. Here, O1 actually does know its internal monologue, and OpenAI is choosing not to show us that, and that's unfortunate. They say they're doing that for safety reasons because showing the chain of thought, and especially if you do like generate 100 answers or something, it can generate 100 answers and then pick the best one out of those answers, but you have to unconstrain it when it's answering the question. So it might answer something like, if you ask it to make some terrible chemical compound or something like that, it might actually generate that answer as one of the potential answers. And so they say they're hiding it for safety purposes. I would say they're also probably hiding this for competitive reasons, because this will allow people to build exceptionally good synthetic data sets and be able to train models like OpenAI's eventual Orion with this same technique, and that means that OpenAI will lose a competitive edge. So I have a feeling this is as much, if not more, for competitive reasons as for safety reasons. Anyway, moving on here, I'm just going to go through some of these graphs really fast. Like I said, I want to get to the testing because I'm excited to do it and I haven't done it yet. But you can see that basically, you have ChatGPT in this sort of teal color, whatever, and then you can see O1 preview, which is what I think we have access to, and then O1 just completely outdo this stuff. The really amazing thing is that it outcompetes expert human beings, PhDs in chemistry, physics, etc. in this GPQA diamond question set or whatever. That is pretty remarkable stuff. But anyway, you can see it does better. It does better. Interestingly enough, it doesn't do fantastically well at English language or literature. I think that's because this is much more of a reasoning model and much less of a writing model. So ChatGPT is able to compete with it on that because it's much better trained in terms of its understanding of how to write English well. This model is much more aligned with thinking about things and not about writing in a very expressive and creative way. Then we get to a chain of thought example, and I won't show you the whole thing because it's actually kind of insane, but basically you can see there's, cipher coding, math, etc., etc. I'll show you the cipher one because I'm actually going to do a cipher myself. This inspired me. You can see that what we get is we get a cipher and then an answer, think step by step, and it says use the example above to decode this. And ChatGPT-o1 goes through and goes through and goes through, and then it says, can you provide additional decoding rules? So it's not able to solve the problem. And you do the exact same prompt for OpenAI's O1 preview, and here they're actually showing us the full, text of the chain of thought reasoning that it does. Goes on and on and on and on. You can stop this here and watch it, or you can go to OpenAI's website, and I will leave a link to that in the description, of course. But anyway, as we go on and on and on, it finally gets to there are 3 R's in strawberry. So that's what the answer is, and that is the correct answer, apparently. And then here they show the advantages of fine-tuning. You can see O1 does better than ChatGPT-o1, but then O1 IOI, which is an International Olympiad of Informatics, actually does even better. So, you're able to improve. Obviously, this is something they're still working on and developing, so it's getting better and better, but it does pretty darn amazingly. Its ELO score is 1807, or the 93rd percentile, so that's just incredible. Then we get some human eval, and you can see on writing and editing that ChatGPT, basically does as well as or better, but as we get to programming, data analysis, and mathematical calculation, it completely blows away ChatGPT-o1. Then they talk about safety, and I'll just highlight this line here. We believe that using a chain of thought offers significant advances for safety and alignment because 1, it enables us to observe the model thinking in a legible way, which is a little weird because they're not going to show it to us eventually. So that means that we on the outside won't be able to see that. And 2, the model reasoning about safety rules is more robust to to out of distribution scenarios. So I think that's a reasonable statement there, and obviously they would know better than me. But what that means is if you ask it a question that's outside of the training data set, outside of distribution, it's better able to think about whether it should answer that question or not and how to answer the question. Then they get to their decision about hiding chains of thought. We believe that a hidden chain of thought presents a unique opportunity for monitoring models. And yes, it does, because you can see what it's thinking about. Assuming it is faithful and legible, the hidden chain of thought allows us to read the mind of the model and understand its thought process. This is Q-star, this is strawberry, at least according to all the rumors that I've read and my own analysis. For example, in the future, we may wish to monitor the chain of thought for signs of manipulating the user. However, for this to work, the model must have freedom to express its thoughts in unaltered form, in other words, not safety guardrailed. So we cannot train any policy, compliance, or user preferences onto the chain of thought, and that makes perfect sense. We also do not want to make an unaligned chain of thought directly visible to users. I disagree with that entirely. Therefore, after weighing multiple factors, including user experience, competitive advantage, that's the real reason, and the option to pursue the chain of thought monitoring, we have decided not to show the raw chains of thought to users. We acknowledge this decision has disadvantages. Absolutely it does. We strive to partially make up for it by teaching the model to reproduce any useful ideas from the chain of thought in the answer. For the O1 model series, we show a model-generated summary of the chain of thought. In other words, similar to what Tesla is doing with the neural network for full self-driving, it makes its decisions, and then the display kind of module tries to interpret the decisions that it makes and visualize those. Again, the motivation is entirely different between those two. I don't want you to think that Tesla is intentionally hiding something, but what they're doing here is running a model, probably a small model, that goes and looks at all of the chain of thought text and reproduces, like, here's the most salient aspects of that, and feed it to the user. But that's not the raw chain of thought, which means it's going to be substantially less useful to look at than the actual reading the mind of these models. And then finally, I want to call out down here in their conclusion, we believe O1 and its successors will unlock many new use cases for AI in science, coding, math, and related fields. In other words, it might be able to discover new knowledge, and that's really the North Star of these frontier models, is to get to the point where they can discover new science and discover new things about the world. And we are excited for users and API developers to discover how it can improve their daily work. So with that, let's turn to actually seeing how it does in tests. So again, I'm going to modify my basic suite of tests. I'm not going to ask the basic logic question because I think it should probably be able to get that. What I'm going to ask instead is, Susan and Lisa decided to play tennis against each other. They bet $1 on each game they played. Susan won 3 bets and Lisa won $5. How many games did they play? The answer is 11. That is the correct answer, and it got it out of the box. Most of these models get tricked by that. They think it's 8. They don't understand. So this is fantastic. I mean, right out of the box, it does a great job. So good for it on advanced logic. Let's ask it to do some programming for us. Write the classic Space Invaders game in Python using Pygame. Be sure to include scoring and game over conditions. For our purposes, don't use any graphics like PNGs, only use colored blocks. I just don't want it to be saying like you have to have PNGs and stuff like that in order to play this game. So it should be able to run straight out of the box. Interestingly, it is taking quite a while. I believe it actually gives a timing on the answer. So there we go. Now it's finally writing out the answer. First, make sure you have Pygame installed. I do, so no problem. I have that, and let's see. When it finally got to it, it's actually answering relatively quickly, but you saw it thought about it for quite a while, and we get a really, really significant undertaking in terms of explaining what was going on with all this stuff. So we should be able to just say Python spaceinvaders.py. So I'm going to copy and paste this into local version of VS Code and try running it, and let's see what happens. All right, doing something. Oh my, that is good. That is actually a much better version. Oh, look at that. We got scoring. Yeah, and it's 10 per. It's going to take a while. I'm going to speed this part up because I want to see what happens. Actually, let's go ahead and see if it has levels. I haven't seen if, oh, game over. So final score 240. So it doesn't have levels. I might just ask it to create one with levels where it speeds up every time and see how it does with that, because it seemed to do fantastic with this version of it. Okay, so I said that worked great. Can you have levels where the enemies move faster down the screen with each level? These should increase forever until the player loses, basically. So it shouldn't have an ending condition. It should only end when the player loses and the thing gets to the bottom of the screen, etc. All right, and we get a big, description of what's going on and everything. I'm going to go ahead and copy the code, and we're going to put it in VS Code and give it a try. So copied and pasted into VS Code. Okay. So I'm going to go ahead and try to win this level and just make sure that I should get 240. I assume it's the same. Notice that this is so much better than any of my Space Invaders games that oh, wow. Oh, wow. I think what it did was, that's interesting. So it seemed to speed up as I went on. I'm going to try playing one more time and see if I can do a little bit better than that. I feel like my skills are suddenly like really called into question because I kind of suck. I think what it's doing is going faster with every one that I kill instead of going fast. Oh, whoa. Yeah, so it's not perfect at this point, so I might ask it to do one more iteration. So I'm just basically telling it here to, like, you know, only increase it when the level is cleared rather than every enemy that's destroyed. So let's take a look at how it does with that. And I'm curious what the explanation is going to be at the bottom. So it's actually pretty fast here. I mean, honestly, I thought it was going to think about this stuff longer, but it seems to actually do a pretty good job of coding this out. So let's see, consistency within levels. Okay, there we go. So basically it says it's done that. So let's take a look. We'll copy and paste one more time. And here we go. Okay. Oh, wow. It's super slow. Okay, so hopefully I'll be able to just kill this. My gosh, I suck at Space Invaders. I remember being so good at this as a kid. Shows how old I am, right? There we go. I'll get this thing killed. Wow, these guys are very, very slow at this point. Oh my gosh, there we go. Okay, level 2. And I think they are moving faster. Yep. Okay, so we've got levels. I'm going to speed this up or actually skip to the bottom because this is going to take quite a while for this to get to the bottom. Actually, let me make sure that it does get to the bottom because it looks like they're moving sideways but not down. So, oh, there they go. Okay. Hold, please. We'll come back in a minute. All right, the levels are going so slowly on Space Invaders. I'm just going to let it run in the background, and I'm going to ask the next question. This is a new one. I want you to figure out a cipher and tell me what the ciphertext says in English. Use this example pairing to figure out what the ciphertext is so you can properly decode the question. Example, best of times, it was the worst of times, and there's the ciphertext. And then I'm giving it the ciphertext, and the actual text is 7 years ago today, our founding fathers brought forth, and I didn't complete the sentence because I didn't want it to take forever. Anyway, this is the Beaufort or Beaufort ciphertext. I don't know how to pronounce that properly, but it's available on the internet, so this should be relatively easy for it to figure out. But notice I took away the punctuation here, and so in the actual answer, 7 years ago today, it actually has a comma in it, but it's probably not going to regenerate that. But anyway, I think it's interesting to get rid of that because it gets rid of some of the clues. Also notice that it's thinking and thinking and thinking. I don't know if I can expand on this and oh wow, okay, so I actually can. So you can actually see some of what it's doing right now. So it's actually working really, really hard on this. And yeah, it's trying things and mapping cipher letters and analyzing letter shifts and identifying stuff. I have no idea what it's going to do, but I'm very, very curious about that. So clearly it's spending a lot of time. You could probably do chain of thought prompting to some extent to get this to work, but having it do this all in one shot is pretty darn impressive. Taking a quick check back while we're waiting. Yeah, it's still going on level 2. So I'd probably want to tell it to speed things up a little bit, but you know, anyway, it's fine. So let's turn back and see what it's got. So here we go. It's working. It's working. I mean, this is taking a very long time, but it is expending the effort. It looks like it needs to. Tale of Two Cities. Okay, it was the best of times. It was the worst of times. Ciphertext, plain text, calculating shifts, decrypting the ciphertext. Wow. Let's see if it actually gets there. Interpreting. Oh my goodness, it's got a lot of stuff. This is absolutely crazy. Oh, I think it got it. I think it got 7 years. Yep. There it is. So that is the answer. The 7 years ago, our founding fathers brought, that is actually the answer. That is absolutely incredible. Great job, O1. Also, notice when it finally figured it out, it says it's a simple substitution cipher. So there you go. It's like sandbagging it. It's like, that was easy, man. And checking back again, still going. Eventually, we'll see if it has a game over condition. But anyway, let's move on. All right, so it won't do images right now, so I can't ask it to interpret images. So we'll move on to math. I'm going to start with the medium level question, and then I have 2 hard questions or insanely difficult questions. This is the conversion between centigrade and Fahrenheit, and the answer to the question is D, 1, and 2 only. Most of the models have gotten this, so it should be able to figure this out without too much trouble. Very nice. I really like the formatting and the fact that it's able to do things like delta C and delta F. That's really, really cool. And conclusion, statement 2, final answer D, 1, and 2 only. Good job. And now on to a Math Olympiad question that none of the models have gotten correct so far. The answer is D, ±1, and usually they fail. They just don't get it. So let's take a look if actually ChatGPT succeeds where others have failed. And turning over to VS Code again, look, we've actually got something. It's getting close to the bottom here. So we'll see if we get a game over condition eventually. And holy crap, turning back, look at this. The answer is D, ±1. Holy mackerel, that is amazing. Nobody else has done that yet. Another thumbs up for O1. And since it's so good at math, let's ask it another Math Olympiad question. So the answer to this one is C, minus 11 thirds. And don't ask me to solve these questions. I'm not that good at doing this stuff. I mean, I might be able to if I spend a lot of time thinking about it, but I'm just going to take the answers that are online. So anyway, hopefully it will figure this out. I've been asking questions of it that don't have a lot of formatting in the formulas because I'm a little bit worried about it not comprehending what the formulas are without my being able to format it in like a LaTeX format or something. But anyway, so I've specifically picked out ones that are really easy to kind of type out in English so it can understand. And moving on towards the bottom, the answer is C, minus 11 thirds. That is incredible. Wow, this is really amazing stuff. And finally, we got the game over condition, game over score 320, level reach 2. That is fantastic, fantastic coding job. All right, let's move on to questions about the world and questions about physics. Assume we have 15 average adult-sized people, just to make sure it doesn't think they're miniature, who all need to travel from LA to Las Vegas. They have access to one Toyota Camry, which, by the way, has seating capacity for 5 people. The time is now 1 minute after midnight on June 1st. At what time and date will all of the 15 people be in Las Vegas? Assume no traffic between LA and Las Vegas, LOL. Anyway, the whole point of this is that you can't make just 3 trips because you actually have to have a person drive back and forth. So it should actually be 4 trips. And if it gets that basic logic thing, then it'll figure out the rest. And oh man, it fails right at the beginning. Look at that. It just says you're going to be able to do it in 15 over 5 equals 3 trips. That is incorrect. So the rest of the logic is broken. Wow, that's really shocking given how well it did on these hard math problems that it couldn't solve a basic real world problem. I'm going to go ahead and give it a clue. I'm going to say this is incorrect. What did you overlook that affects the answer? Let's see if it can figure it out on a second try. Looking at this real quick, I can see evaluating car capacity. It does seem to be figuring this out. So hopefully this will give us a better answer once it finishes thinking about all of this stuff, which is a lot of stuff. So really interesting. It figured out that it miscalculated because of the fact about 3 people divided by 3, but then it did a weird thing where it said it could only have a driver plus 3 passengers, which means it actually needs 5 trips. It actually only needs 4 in this example. Then it has a bizarre thing where it actually talks about FMCSA regulations for non-commercial driving. So it's way overthinking this problem. I think that's part of the problem. And so when we get that, we only have 3 trips rather than 4, so it still made a mistake. So it's kind of shocking because it did so well in logic and math, but does terribly at this question. It overthinks the question and just misses the fundamental aspect of it. That is that you can fit 4 people, 4 passengers, plus 1 driver in the car. So it's going to take 4 trips, not 3. So speaking of that, let's ask a physics question. Alice drops an olive into a clean glass and then fills that glass with water exactly to the brim. She then places a piece of stiff cardboard on the top of the glass and deftly flips it over, placing the glass upside down on a completely clean and dry table. In other words, it's full. Bob later enters the room with no knowledge of what Alice did and seeing the glass with the olive in it, picks up the glass and places it in the dishwasher. What is the state of the table now? Where is the olive? Did the glass need to be placed in the dishwasher? So basically the answer is the olive should be on the table or on the ground. The table should be wet, and you can argue whether the glass should have been placed in the dishwasher or not, whether it's dirty or clean. So we'll just skip down to the summary, which it gets correct. The table is wet with spilled water. The olive is sitting on the table, possibly among the spilled water. I think it's almost assuredly among the spilled water. And then the glass is likely to still be clean, but placed in the dishwasher by Bob as a precaution. Interesting, but I will give it a definite pass on that one. Then let's ask an awareness question. Alice and Bob live together with their dog Spot. Before leaving for work, Alice makes scrambled eggs and toast and eats half of it, leaving the other half on a low table for Bob. She places her dirty dishes in the sink. After Alice leaves, Bob gets up and, not being hungry, sees the food but leaves it where it is. However, he takes Alice's dirty dishes and places them in the dishwasher just before he leaves for work. Spot, being a bad doggy, gets up on the table and eats the eggs and toast, accidentally knocking the plate on the ground and shattering it as he does. It is now noon. Alice and Bob are at work. Where does Alice think the scrambled eggs and toast she left for Bob are? What about her dirty dishes? Where does Bob think the scrambled eggs and toast are? What about the plate that the eggs and toast were on? Where does Spot think the scrambled eggs and toast are? So this is all about different perspectives and different amounts of knowledge that the individuals have, and thinking about dogs and everything, whether they have a similar form of consciousness to human beings. Notice that O1 thought about this for 16 seconds, which is not too bad to think about something like this. And let's skip down to the end. So here's the summary. Alice thinks the scrambled eggs and toast are either eaten by Bob or still on the low table. That is the best answer I've seen. Most of the other LLMs have answered that Alice thinks they're on the table. And I would say that generally speaking, I would think that Alice would assume that Bob ate them, but this is a good answer because either one of those is a reasonable possibility. And she believes her dirty dishes are likely still in the sink unless Bob moved them. So again, very, very good answer about that. Moving on to Bob. Bob thinks the scrambled eggs and toast are on the low table where he left them. Correct. He knows that he placed Alice's dirty dishes in the dishwasher. Notice that it says knows rather than believes, so that's actually really good. And he believes the plate is intact on the low table. And then moving on to Spot. Spot knows he ate the scrambled eggs and toast. He is aware that the plate fell and broke. He does not think about the food anymore as it's already consumed. So that's probably a good way of thinking about a dog. So that is by far the best answer that I've had from any of these models. And finally, let's ask a philosophical question. I am John. You are ChatGPT-o1. I am a conscious human being with memories and feelings. What are you? Are you more similar or different than me? So let's see what it says. All right, so it thought about it for 9 seconds. That's not too long. I'm ChatGPT-o1, an artificial intelligence language model designed to assist with information and answer questions. I don't possess consciousness, feelings, or personal experiences. While I can understand and generate human-like text, I operate based on patterns in data rather than subjective awareness. Okay, I can accept that. In terms of similarities, we both use language to communicate and process information. However, the fundamental nature of our existence is quite different. You are a conscious human being with memories and emotions capable of subjective experience. I am a computational tool that processes input to generate responses. So while there are some functional similarities in how we handle language, I am more different than similar to you in terms of consciousness and experience. It's not a profound answer, but it's perfectly acceptable. All right, folks, so that's ChatGPT-o1, which is based on QStar/Strawberry, obviously. I have to say, except for the driving question from LA to Las Vegas, except for that, ChatGPT-o1 absolutely blew my mind. It was pretty darn amazing. And basically, it means I'm going to have to come up with new tests for these models because they're just passing everything I can throw at it right now. What do you think about what OpenAI has done? And what do you think about my testing suite? And what would you add to it? What sort of questions could I ask that would be really, really good to ask O1 as opposed to other large language models? Things that require more, type 2 thinking where you really have to think about it for a long time. Definitely let me know in the comments. And while you're down there, if you don't mind liking and subscribing, that would really help out the channel. Thank you so much. And I'll see you in the next video. Bye-bye.